Good morning, scholars. Today we are going to be talking about how to solve linear systems graphically. So go ahead and pause the video, take a moment to write down your title and your objective for today's lesson. All right, welcome back. You probably, hopefully, remember from Ms. Babb's lesson yesterday. She said there are 3 different ways to solve systems of equations. All a system is just more than one equation that we're looking at the same time. So she said there were 3 ways, and she yesterday talked about using elimination and using substitution. And so today we're going to look at the 3rd way, which she did not yet discuss, which is solving linear systems by graphing them. So in order to do that, the first thing we're going to do is just review how do we graph equations. All right, so I've set up down here a very imperfect little graph. All of the practice problems for today's lesson are going to be on Delta Math because I know it's a lot to just kind of freehand and draw graphs. So we've put it onto Delta Math. So I'm going to go ahead and let's look at, we'll start with this. Y equals -1/5 x plus 3. I know that might be a little bit light. This is in slope-intercept form, and how do we know that? We have y equals, we have our coefficient in front of the x, and then we have our number here. So if you remember, just really quick, y equals mx plus b, and we've talked about this 1,000 times. It's really just a recipe or a model that shows us where things should go. So the m, again, is the slope, and the b is the y-intercept. So again, this is called slope-intercept form because it gives us the information of slope and y-intercept. So this would be the slope, -1/5, and this would be the y-intercept. So what I'm going to go ahead and do is use this blue color right here to graph this particular line. Again, I start at the end. So I start with the y-intercept, which is a +3. Y-intercept always goes on the y-axis. Again, y-intercept, y-axis. Okay, so we're starting with +3. So we'll start by making our first point right there on the y-axis. Okay, now we're going to use our slope to find the next point. So the slope is telling us -1/5. Now what this does not mean is -1/-5. Okay, because a negative divided by a negative would just be positive. Okay, what this does mean, we apply the negative sign to the numerator. Okay, so we're going to say from this point we're going to go down 1. We're going down because this is a negative. So we're going to go down 1. And then we're going to go over 5. Now, it's a +5, so we're going to go to the right 5. So we're going to count 1, 2, 3, 4, 5. And that is where our second dot goes. So again, we use the slope to help us find the second point. So then once we have 2 points, all we need to do is go ahead and draw our line and connect our 2 points. So you can use like the edge of a paper or a ruler if you have one. I don't have a ruler right now. So again, I'm going to go ahead and create my line. It's a little bit messy, but there we go. All right, let's go ahead and look at another one. This one, I will draw an orange. This one's very similar, but it has a key difference in that the slope is actually not negative. All right, so again, we start at the end. We're going to put our first point on the +3 because that's the information that this +3 is giving us. Now from here, we're going to use our slope. It's a +1 and a +5. So we'll go up 1 and over to the right 5. So that will be our second point. So to graph this line, we will simply connect our 2 orange dots. And yes, our blue line and our orange line cross. That's fine. Don't worry about it. So those are our 2 lines there, okay? I want to go over 1 or 2 more and then we'll get on with it. So let's do one in red now. Let's say, what if y is equal to 2x minus 2? Okay, so now we have a -2 in the slot where the y-intercept is. So we're going to go ahead and make our first dot right here at the -2 on the y-axis. Again, our first point always going on the y-axis. All right, now we have a 2. This is not a fraction, so it doesn't really give us a rise over run slope situation, but think about this. This right here, we can rewrite this as 2 divided by 1. So that means our rise will be 2 and our run will be 1. Okay, so from this point, we'll rise up 2 and we'll run over 1. Again, we went up 2 because it's a positive 2. And we went to the right 1 because it's a positive 1. So again, we went up 2 and over 1. That's where we make our second point. And then we can go ahead and connect our 2 points. So this should all be review for us, but I just want to make sure we're on the same page. Okay, what if you run into a scenario? So I'm going to write this scenario down. What if the equation is not in slope-intercept form? So if it's not in slope-intercept form, we are not yet ready to graph it. What we need to do is we need to put it into slope-intercept form. So we put it in slope-intercept form by solving for y. Now I've run into my next graph. Oh well, by solving for y. So let's look at an example. Here's an equation. It has an x and a y in it, just like the equations we were looking at above, right? These all had an x, they all had a y, they had other numbers involved. But if you notice, all of these had the y alone on this side, but that's not the case here, right? The 3x and the 6 are also over here with the y. So what we need to do is we need to solve this for y. So again, as you talked about 2 days ago in Ms. Babb's video about solving equations, we're going to take the same approach here, even though there's variables, or there's more than one variable, excuse me. So what I'm going to do first is I'm going to subtract 3x from both. Oh, nope. What I'm going to do first is draw my river. Then I'm going to subtract 3x from both sides. So over here that cancels, leaving us with a 6y. Now over here, 24 and negative 3x, they're not like terms, so I cannot combine them. So I simply need to use both of them. Negative 3x plus 24. Now the reason I put the negative 3x in front of the plus 24 is because looking back up here at slope-intercept form, the x term we usually write first, and we write the term with no variable, or the constant, last. So I'm going to want to have my constant written last. And it's fine for me to rearrange the order as long as I keep the correct sign with the correct term. So this negative goes with the 3x, and the 24 is going to be positive since it does not have a negative sign. Okay, now there's only one thing left for me to do, which is to divide both sides by 6. Okay, over here that leaves me with y equals. Now because this is a large division problem, I'm going to split it into 2 pieces. So the 6, I'm going to use that to divide each term. Okay, this is just the process of simplifying because, again, this doesn't really look like this form up here. Okay, so let's keep going. We're almost there. Negative 3 over 6 is the same as negative 1 over 2. Okay, plus what is 24 divided by 6? 4. Okay. And you can see also I have this x in the numerator above the division sign, whereas these x's are kind of out on their own. That's the exact same thing. So you can rewrite this as with the x right there, or in the numerator, it doesn't matter. But now we recognize that we have found slope-intercept form, and we can now go ahead and graph right over here. So again, we're starting with the plus 4. Okay, from there we need to go down 1. Remember, this negative is going to apply to the numerator only. Down 1 over 2. We'll go to the right 2 because, again, the negative applies to the 1, not the 2. So we'll go down 1 and to the right 2. Okay, once we have our 2 points, we can go ahead and draw our line. Okay. So that's just kind of a review of how we are going to be graphing. So now I'm going to do just 2 more examples with solving systems. So let's go ahead and turn to the next page. So a system of equations, let's see, I'll go ahead and give myself a little title here, solving systems now. What we're doing is we're looking at 2 equations at the same time, and we're saying, can we find x and y such that both of these equations are true at the same time, okay? So what we're going to do here is first we're going to notice, okay, they're already in slope-intercept form. How do I know that? The y is on one side, equal to, then we have an x term, and then we have a constant, okay? So we are in slope-intercept form, so we're ready to go ahead and graph. So I'm going to go ahead and graph these two. I'll just quickly draw a graph here. But like I said, you will have Delta Math, so you will be able to do the graphs on the computer. That should be a lot easier. Okay, so let's go ahead and graph each of these. I'm going to say my first one, I'm going to do that in red. So let's start. So we have a positive 3, so again we start right here at positive 3. Now there's no number out in front of the x, so if there's no coefficient, what do we know that to be? Good, to 1. Again, if there's no fraction here for the rise over run, we divide by 1. Okay, so the rise will be 1 and the run will be 1 as well. And both of those are positive. So we'll rise up 1 and to the right 1. That becomes our second point. I'll go ahead and again use my straight edge or my paper to draw my line connecting those 2 points. So this is the graph right here of this particular equation. Okay, now let's do our second equation in green. We'll do Christmas colors. Okay, so again, we start at the end with this -1. We'll go ahead and plot that on the y-axis. Now we have a -3. Again, there is no fraction, so we make it 1. We have that -3, we just divide it by 1. So -3 becomes the rise, 1 becomes the run. So a rise of -3 is actually going down. 1, 2, 3. And the run is 1. It's a positive 1, so we're going to go to the right 1. Again, we use our straight edge. Now, when you do this, you're going to see that our 2 lines cross. Okay? Our 2 lines cross, and where do they cross at? Let's go ahead and label the point that they cross. This right here is what we call the solution to the system. This point is the solution. So now our only job left is to say, okay, well, what is this point? Well, what are the coordinates of this point? So in the x, it's over to the left side 1, so the x coordinate would be -1. And y, it's up 2 from the x-axis. So here would be our point. So we would call this our solution. Right there. Now, how could we check this? We know that the first number in an ordered pair is x, and the second number is y. What I can do is I can substitute the x and y into my original equations and see if they're both true. So my first equation, I'm just going to rewrite it. It was simply y is equal to x plus 3. Okay, so let's go ahead and substitute in. Again, x was -1, so I'll put that where the x is. And what was y? Y we said was going to be 2. So I'll put that where the y is. Now I need to simplify each side and see, is this true? 2 equals, what's -1 plus 3? Well, it's just 2. And 2 does equal 2, so we're good. But we're not finished because we need to go ahead and check our second equation as well. Our second equation was simply y equals -3x minus 1. So again, we said that our x was going to be -1. So I'll go ahead and put a -1 where the x is, being really careful to put that in parentheses. You're going to put any negative number in parentheses when you're writing this out so you don't mess yourself up. And we said y would be 2. So now we're just going to look at each side and simplify it and see if we got what we're looking for. So 2 on the left-hand side. So -3 times -1 is a positive 3. We still have this -1. Okay, so let's keep going. 3 minus 1 is simply 2, and 2 does in fact equal 2. So we've checked our point. Again, once we graph our 2 lines, we look at where they intersect or where they cross each other, and that is our solution. All right, so you're going to get some practice with all of this in your Delta Math for today. Keep in mind that if your equations don't start out in slope-intercept form, again, just like we practiced on the other page, all you have to do is turn them into slope-intercept form, and then you'll be ready to graph them, okay? So please feel free to reach out if you have any questions. Good luck. Have a great day.